Sea level rise is another climate change impact that is very critical for adaptation. The number of people living within 50 miles of the coast is about 50% and is expected to continue to increase. And the option of moving away from the coast is not a very popular one with many communities. So then you need to have a very good handle on how bad the sea level rise is going to get. And these are the typical images you would see. There is a historical sea level rise, so it's a anomaly with respect to the global mean. So this is the global mean sea level, and just like temperature, we have to start by saying that nobody lives in the global mean sea level. So local projections, regional projections, and regional observed trends and variabilities are going to be critical, especially in regions where stronger hurricanes or increasing number of cyclones, typhoons, and so on are going to be very critical in terms of changing a little sea level rise into a large sweeping in of inundation and storm surge. All right. So tide gauges are combined later on with the satellite data here, and then the model projections are tagged on. And you can see that there are uncertainties or standard deviations that are going to be large in some places, but as you get closer to the satellite period, the data gets more dense and the assessment is getting much more accurate, and the deviations drop off and we get much narrower error bars. Okay, there are various constructions here, but we will just look at the IPCC projections for very high, so almost business as usual RCP 8.5 projection, which would say almost close to 1 meter rise by 2100, and then you have the RCP 2.6 scenario here in the blue, which is the way to keep global warming to less than 2 degrees. So this is a good indication that when we use only the temperature target as something to hit in terms of our impact on climate, we don't always account for the related cascading effects on sea level, vegetation, crop yields, health, etc. Especially at local and regional levels. Global mean of 2 degrees centigrade warming may mean a very different thing at local level for especially island states, coastal communities, and so on. Keeping that in mind, look at the global map of the mid-range scenario of RCP 4.5. This is showing the global range of sea level for 2081 to 2100, so the end of the 21st century. This top panel is showing model mean with 50 centimeter global mean rise, but you can see that there are definite patterns here, with the AMOC region showing up here again. Great Lakes are resolved in some sense, Arctic, but the Indo-Pacific warm pool and the expansion of the tropics in these oceans is fairly clear. But you can see that regional sea levels matter. So you have very high sea level here in the US East Coast, whereas you have somewhat of a lower sea level here around India. So what are the uncertainties? So if you look at the uncertainties here in terms of the low and high end of the uncertainty, this is almost close to 0.1 meter, which is quite tolerable, even combined with the potential increase in more intense cyclones, or even just number of cyclones. But the high end of the uncertainty changes that to more than half a meter, almost 60 centimeters. So the range is very large when you get to local levels. So this is something that has to be dealt with, especially if you see the regions here which are more vulnerable. you can go from something like half a meter to more than a meter here. So how to plan for such uncertainties in sea level rise, that's going to be critical. Model reconstructions are done to increase confidence in them. So you see here reconstructed sea level rise going back to 1900 shown here in terms of the different reconstructions. They are up here with the satellite period from Topex, Poseidon, Jason, and so on, the altimeters being shown here. And you can see that the CMIP 5 models, not considering Antarctic peripheral glaciers, are down here. And then some adjustments are made to include several contributions that are not included in the CMIP 5 models. For example, not all of them had land glaciers and so on, and including observed ice sheet contributions. So since they didn't have ice sheet contributions, you add it on and you get pretty close to observed estimates. So these are the range of individual models here, and the uncertainty is quite large, and you try to somehow adjust, but this is at a global mean. When you try to go to local levels, this uncertainty is still very high. This is showing the rates of sea level change for the same period, and you can see that even the reconstructed data have lots of differences in them, and the CMIP 5 models basically do not have these large swings in rate of sea level rise that is shown here, and the altimeter data is up here at the end. Okay, so uncertainties remain, and this is again showing 1961 to 2010. I won't go into the details again, but you understand that adaptation to sea level rise is very critical, one of the most critical things considering the growing populations that is already high near coastlines, and the direct impact of warming in terms of steric sea level rise and the eustatic contribution from glacier melt is going to make this a critical climate variable to observe for and get ready for. Okay, so regional sea level trends for the satellite period from 1993 through mid-2018 with the global average rate removed shows that there are large differences in sea level, regional sea level trends in millimeters per year. There are some hotspots up here, for example. Glacier melt over Greenland makes a difference here because dynamical adjustment as well as the gravitational pull is reduced when the glacier begins to disappear. Okay, there are high variabilities, of course, in western boundary current regions and so on, but you can see that having a handle on these kind of regional scale changes is not very easy for models. So this is showing another example of India for Mumbai city here, which is an island city. 2050, the earlier estimate was is shown here, but the newer estimates put it at much higher sea level rise. Okay, I'm not showing the scale here, but the reds are order 50 centimeter to 1 meter, I think. Okay, so if there is already a strong warming in the Arabian Sea and there are signs of increasing cyclones, maybe it's interdecadal change, but maybe it's a trend. But as I said before, sea level rise with cyclones is going to increase the vulnerability of these regions greatly. So sea level rise and hazards and risks are computed with some detailed modeling framework here that combine data as well as rainfall, coastal conditions, hydrologic conditions, terrain conditions. So even the digital elevation maps are used to do this very well, including land use, land change, bathymetry of the coastal regions as you come in, and so on. So the Bay of Bengal, which is already a very warm region, and Bangladesh sitting up here with all its estuaries and islands and so on is basically mostly within 1 meter of sea level rise. So even 50 centimeter of sea level rise is going to be bad news for Bangladesh. And not just to add another point, the issues of Bangladesh to this geopolitically sensitive region of China, India, Bangladesh, Nepal, Pakistan, Burma, and so on. Climate change is going to be a security risk as well, so one has to worry about those sorts of things as well. So we'll come back and look at hydrological modeling, which is critical for doing the coastal land continuum as well in terms of groundwater exchange, salt inundation, as well as crops, vegetation, health, water resource management, and so on, water security, food security, and so on land. So again, hydrological modeling is very much part of the Earth system, but we'll see that typically hydrological models are run in what is called an offline mode, where the climate model simulates the climate and the hydrological model is forced offline, and this has some specific issues that have to be dealt with when it's done that way. So sea level rise, critical issue, needs very local and regional information, and the uncertainties can still be a problem. But the good news may be that even if the sea level rise, I don't know if it's good news, but it's a practical way of dealing with it. Even if sea level rise is projected to be, let's say, 1 meter for a city like Mumbai, it has to decide how much can it really invest in protecting against sea level. It may only be able to afford against 0.5 meter sea level rise and then take a chance with that going to 1 meter. Okay, so moving back from the coastline may get forced at some point if there are repeated inundations and so on.